Now we're going to solve these inequalities. These are a little bit trickier to solve than the normal inequalities because these are rational inequalities. We're dealing with variables in the denominator. So the first thing I would like us to do is realize, first of all, what can t definitely not equal? What would be a bad number to plug in there, right?
0.
0, good. So we're going to say t cannot equal a 0, okay? Now, we're also trying to figure out what values of t can I plug in there to make this side, what, greater than this side, right? What we have to figure out is not just one answer, but all of the answers that work. One answer we know that does not work is t cannot equal a 0. So what I'd like us to do to start this out, we're going to make this as easy as we can. Instead of using the greater than sign, let's just set things equal to each other. Because I'd like to also figure out what value of t would have to go here for this side to equal this side. Okay, and then we're going to put things on the number line and see what scenarios could possibly work. All right? By the way, if we're going to solve for t, what is the least common multiple we're going to multiply everything by? T. T is correct. So what I'd like you to do right now is take a t and multiply it to this one, and to this one, and to this one. You started out right. So what do we have? We have a 6t over t, which just simply is a 6, plus 3 times t, so that just stays the same, 3 times t, equals 2t over t, which is equal to a 2. Now, if we're going to solve for t, we have to subtract 6 from this side and subtract 6 from this side. So we have 3t equals a negative 4. And if we divide both sides by 3, t equals a negative 4 thirds. Okay? So t is equal to a negative 4 thirds. Which means this. Which means if we plugged in a negative 4 thirds here and here, that both those sides would be equal to each other. Okay? So right now what I'd like you to do in your journal, I'm going to leave it right here so you can see it. I'd like you guys to draw a number line. Okay? I want you to label one of them right here at 0. And we're going to make this a negative 1. Make this a positive 1. Make this a negative 2. And right here, I want you guys to understand, right here, this is where about negative 4 thirds would be. And right here, we know what? We know we can't equal a 0. And technically, we don't want one side, we don't want one side to be, right, third time's a charm. Here we go. All right? We can't be equal to, right? So since we can't be equal to, what I'm going to do, Liz, is I'm going to open that. Oh, man. Oh, no. Okay. I need to put an open circle there. An open circle here, and an open circle here. So we have a negative 4 thirds, and we have, right here, we have 0. So here's the situation that can happen. Either our answer is going to be between these two numbers, okay? Or the answer is going to be going from here this way, or here this way. So let me show you the possible answer choices, okay? One of our answers could be between a negative 4 thirds and a 0, where you connect and you do what? You shade everywhere in between. Now this statement would be an and statement, okay? Where you would say all the values of t are less than 0 and greater than negative 4 thirds. That could be one of our answer choices, okay? The other answer choice could be an open circle at negative 4 thirds and an open circle at 0. And what could you have? You could have things going in opposite directions. 1 second, let me finish this real quick. So this would not be an and statement, this would be an or statement, and you could say t is less than negative 4 thirds, or t is greater than 0. So we're going to have this situation, or we could have this situation, or maybe nothing else. Okay? We know that 2 works, right? We know that what? Yeah. So what you're going to have to do is you have to figure out, okay, it's got to be this guy, or it's got to be this guy, and then what do? You test numbers, and Isabel, you said we already know that what works? 2. Because before we started the video, Ryan was like, well, 2 works, because if you plug in a 2 here, and you plug in a 2 there, this side is greater than the other side. Now, the next thing I want you to know is we can actually do this in the graphic calculator, too. Thank you, Ryan. You're awesome. Let's do the graphic calculator. So, I want you guys, right now, I want you to take this right here, and this right here, we're going to put them in the graphic calculator. I'm going to show you how. So, here's how it works. Liz, can you tell me the left side? I'm going to put it in blue. The left side of the inequality sign, what's the rational expression on the left side? It's, yeah, no, the question. 6 over t plus 3. Okay. 6 over t plus 3. And then in red, I'm going to write y equals 2 over t. So what I want you to do right now, maybe by seeing it, you will believe it. All right? If you guys are doubting Thomases, you can see it and believe it. So Liz, go to y equals. All right? Hit alpha y equals, enter. Type in 6, but instead of a t, I want you to put in x. And we'll say plus 3. Here, go alpha y equals, enter. And do 2 over x. Now, before I hit graph, I want you guys to understand, once again, we are going to look at the graph where the y values of this graph are greater than the y values of the other graph. So we're going to look for the blue y values, because remember we hit y equals, right? And we're going to see where are they bigger than the red y values. So once you guys hit graph, let's look at the blue y values and look at the red y values. So right here, there's an interesting point right here. Do you know where that point is located? What do you think?
-1, -2.
How about this? Here's what I want you to do. You ready? It is -4/3. Watch. It's second, trace. I want you guys to find a point of intersection number 5. All right? We're going to hit enter. And then enter. If it works, come on. Hold on, give me a second. Trace, point of intersection. There's the first curve. I'm going to go over here to the left. I got to go to the left. Here we go. Now you have to see the cursor. There's my first curve. There's my second curve. You see it blinking. Press enter once again. Look where it's located, everybody. What does it say?
-1.3.
Which is -4 over 3/3. So right here, this point right here is at your -4/3. Would you guys agree that the blue graph is greater than the red graph, anything that's going which way? Less than. So where all the x is what? Is less than a -4. So yes, let's how about this? Ready? From -infinity all the way over to -4/3, not including it, union with open, what number am I going to put here? No. 0. Because look, right here, you guys see over here, it's not technically equal to 0. No. Comma. Positive infinity. Now this is called interval. No brackets.
Not on the 0.
No, it's not. It can never equal 0.
You can't include it.
You can't include it. Because what was our symbol? Our symbol was greater. When is it greater? Not equal to. So this is called interval notation. And you will need to know, you'll be introduced to this. Well, we've already been introduced to it a little bit. If you have a college algebra class, I work with y'all. Okay? This is interval notation. But all I want you guys to do on your paper, everybody, for this question. Alright? Now that we've done this, your two answers are where t is less than negative 4/3 or when t is greater than 0.
So how do you divide by 100?
So interval notation was, that's, if you want to do it, that's fine, Liz, alright? Negative infinity, comma, negative 4/3, soft bracket because it's not equal to, union with 0, comma, positive infinity, no hard bracket because nothing is equal to the answer. They're both the answer, but for the majority of you, just put this right here. Alright?